Alright everyone, welcome back to my channel. So today I'm gonna do a problem called the maze. So there is a ball with a maze with an empty space represent 0 and the walls represent as 1. The ball can go through the empty space by rolling up, down, left and right, but it won't stop rolling until it hit the wall. When the ball stops, it could choose the next direction. Given the m by n maze, the ball will have a start position. So you have a start position and it also have a destination. Return true if the ball can stop at the destination, otherwise return false. And then you may assume that on the borders, on the borrows of the maze are walls. Like this. This is an example. So you can say that if this is gonna be a modify of the DFS or BFS function where you can, so for this particular problem, I will just gonna use DFS function, and let's say using DFS, I can traverse to the grid to find the solution, right? And since this one is the modified DFS, the only thing that is different is the task where the ball hit the wall, right? And the ball will keep rolling up, down, and left, right. So let's try to demonstrate it like this. Let's say from this position right here, you want to move the ball to the left, right? Or going down, right? But in normal DFS or BFS function, this ball will just roll to this point, right? It goes to the neighbors, which is this, right? It's just going here, and you find the next position from this point, right? But this one is a little bit different. This ball, it will roll all the way to this bottom right here, right? And then from this, and then since it hit the wall right here, it cannot move any further. It stopped right here. So this is the next position in our, we can just think of this in normal DFS. We have a direction. Let's say we have a direction to go up, down, right, and then left and then right, correct? And then for each position you have a new row and new column. After that, new row and new column, right? So you have these two new column. The modified part of this function is I'm gonna create an helper function to get me the new row and new column. And in that modified function, I will just keep rolling the ball. I will have the row and column, and then I will keep incrementing, or in this case, incrementing the row right here until it hit the wall or it outbounds, so I can return this point. And if the row and column won't change, I will just stay here, right? And the DFS function, when you say it at the exact same spot, it will just back. So more than just talking, I will just go straight to the coding, and then from the regular DFS function, I will upgrade that to fit for this solution. So let's try to code it up. Oops, right here. So let's start with a regular DFS function right here. We have the row, we have the column. So row would be length of maze, right? And then the other one is the maze 0, right? So right now I have the direction. It's just simple 0, 1, right? This one is 1, this one is 0, and this one is 0, negative 1. Then I also have a visit, which is standard for DFS or BFS function. And I just simply do a DFS function right here, which we will take the row and the column, right? So in here, let's say if my row and column in visit, right, which means it spaces again, so I will return false. If my row is gonna be equal to my destination, or the column, oh wait, actually, and my column at the destination of 1, like that, I will return true. And then I will just do a visit dot add row and column right here, right? So for the direction column, in the direction, right, I will have a new row and new column, right? Which is regularly it would be regularly it would just like row plus the direction row and then column plus the direction column, right? And if DFS of new row, new column, I would just return true and return false right here, right? And then in normal BFS right here, I will have to need to check if it's out of bounds, right? Out of bounds or hit the wall, which is the one in the maze, right? So I check this. I got the new row, new column, so I check it in here when I recall that in my DFS function, right? So the modify part is just the new row and the new column in here. Since we will roll it inside of an helper function, we're also gonna check if it is out of bounds or it hit the wall inside that helper function. So my helper function, I will call it, let's say, row, right? And I would take the current row, current column, direction column, and on the top right here, I just have another function, say row, right? I have my column and column, direction row. So my row is, I will create a new row, a new column here, so I can keep rolling that. I have my while loop right here, and I will have another helper function called canRow. This is where I check if the new row and the new column is actually out of bounds. If it's not out of bounds and it can roll to that position, I would just simply increment the row and the column. Let's say like that. So base split equal to direction column, and then in the end we just return the row and the column, row column. So let's say if nothing happened in here, right? Let's say you're at this wall right here, and then you're trying to move to your right. It hit the wall, so it's returned the exactly same position. Since it's exactly same position, and I already added to visit, it will return false. So when I call it in this DFS right here, so that's why I do a return right here as a new row and a new column. And right now I just need to do a canRow function. So canRow, I will have my row and column. So this is where I do the checking. So if min of row and column is smaller than 0, out of bounds, I will just return false, right? If the row equals to row, and then or column equals to column, right? I just return false. If it is a wall, so if maze of row and column equals to 1, right? I would just return false, and then at the end, if everything is good, I would return true. So that is just minimize like the code I have to put in here for my while loop. And then at the end, I just need to return my DFS function, which is using the start point, right? Start of 0 and start of 1. So far so good. And then let's see if everything is correct. Let's run it. Yep, it's look good. And let's try and run this. Yep, everything is good. So for the time and space complexity for this problem, it's gonna be just simply O of n times n, right? Because it needs to be traversed to all the cell in here, and also the space complexity is gonna be also O of m times n. The worst case is have all the nodes inside the grid and the DFS cost stack. This one I also missed this part, so it's also times the maximum of the length and the grid, the row and the column of the grid, because when it's row, it's gonna have a while loop right here. So it's worst case it's gonna loop through the n columns or n row in this case. And if you like the solution, consider a like and subscribe to the channel, help us a lot, and thank you so much. See you soon on the next video.